icy cold and hardly a drop of water. The death trap they call the desert. Yet through man's ingenuity, he's not only survived, but thrived here. The complexity of irrigation systems, the comfort of air conditioning, the promise of solar energy. From ancient times to the present and beyond, man has transformed barren wastelands to worlds of wonder. Now, Desert Tech on Modern Marvels. The desert. By day, the sun beats down hellishly without mercy. On a winter night, the chill wind blows through canyons with an icy fury. But it's really all about the water. Deserts typically get less than 6 inches of annual rainfall. So finding and maintaining a water supply means everything. It's an enormous challenge. Some 40% of the Earth's land is desert. So throughout time, man has, by necessity and by choice, had to cope with it, cross it, survive it.
We started out in the desert and we've evolved increasingly sophisticated technologies that have allowed people to live in what are some pretty horrendous environments by anybody's standards.
Our religions grew in desert environments. The desert is a testing environment where you find out what you're really made out of.
In order to live here, people have had to organize, invent new technologies. People have had to come to grips with living within the environment in a way that they weren't forced to in many other parts of the world.
In the Middle East, where arid desolation dominates the landscape, people are surrounded by great bodies of water. But none of it is drinkable. Still, desert technology allows millions to live along the coastlines. Since the 1970s, as its oil-rich societies have expanded, the Middle East has increasingly relied on desalinization, also known as desalination. This is a process that removes salt from seawater. Seawater from 5 surrounding oceans and seas can be diverted toward the desert's populated areas for drinking, bathing, and irrigation.
About 90 to 95% of the water in the world is salty water, and you can't use it. Desalination has to be a part of our long-term water resource management strategy.
The salt content of seawater is approximately 33 to 34,000 parts per million. That content must be reduced to just 350 parts per million to make it drinkable. To accomplish this, desalination plants run a widely used system called reverse osmosis. After water is pre-treated to remove common marine debris, it flows through a pressurizing unit and then travels through a filter porous enough for water to flow through, but too small for salt molecules to penetrate. Once completed, the process yields a waste byproduct of salty water that must be discarded.
So the question is, what do you do with the salty water? Living near the ocean or the sea, you can dispose of this right back into the ocean and the sea. So that's why that makes sense in the Middle East.
Desalination requires a lot of energy and is therefore extremely expensive. It costs over $650 per acre-foot to desalinate seawater, as compared to about $100 per acre-foot to purify water from conventional freshwater reservoirs. But when you have no choice, as in the desert, the cost is unavoidable.
So only really in situations where energy is cheap and the demand to live in a place without surface water is large, does it make sense to do it.
In ancient times, without the benefit of desalination technology, the only parts of the desert where people could live permanently were those that bordered rivers or were situated on oases. An oasis is a desert area where water from an aquifer, an underground pool, has seeped to the surface. Societies could also settle in areas separated from the water by diverting the rivers to their remote locations. 6,000 years ago, in the harsh environment of ancient Mesopotamia, a resourceful culture thrived for millennia. They conquered the desert by ingeniously utilizing the waters of the Euphrates and Tigris rivers. The region today is the site of modern-day Iraq.
They were able, primarily through irrigation, to produce tremendous quantities of agricultural food, and they were really converting what otherwise to you and I would seem like a tremendous desert into agricultural fields as far as the eye could see.
But perhaps their most spectacular achievement was the creation of the Hanging Gardens of Babylon, one of the 7 wonders of the ancient world. Since Babylon, the capital of Babylonia, was a desert city with little rainfall, the gardens had to be irrigated. The source of the garden's water was the Euphrates River. The water was dispersed by a slave-powered chain pump, which had 2 large wheels like a ski lift. Ceramic pots or buckets hanging from the chain were continuously dipped into the reservoir at the base of the gardens. Once the water reached the top of the gardens, it was released from gates into irrigation channels.
Those gardens also created evaporative cooling, so that in fact it was a wonderfully cool place to be, even in a hot, dry desert.
The renowned gardens were just a part of ancient Babylonia's architectural strategy to combat the scorching desert climate, where temperatures could rise as high as 120 degrees.
They found ways of creating a lot of shade. They found ways of grabbing whatever wind there was and channeling it down into the houses. They built with very thick walls and very thick roofs. Many what we would call passive technologies were used in those days.
Specially designed Babylonian homes helped the people stay cool in the desert. They have stood the test of time. Courtyard houses featured shady plants and trees, and typically, a pool. As the water evaporated, it created cool air in the courtyard, which could then flow inside the home through several open doorways.
One of the wonderful things about the desert is you get this big change in the temperature from day to night, as much as 30 degrees Fahrenheit, so that they can throw those doors open and get that cool night air into those rooms.
Babylonian architects helped home dwellers beat the heat with another design, reminiscent of the biblical Tower of Babel. The Tower House, still popular today, was typically 8 or 9 stories, and people lived on the top.
First of all, you have access to the cross breezes when you get up high. Secondly, because of the cold night air, it cools off very rapidly at night. Then on top of that, the very tops of these houses are covered with a white plaster, and that's highly reflective. So in fact, they don't gather much heat at the top at all.
As the Mesopotamians flourished in the hostile desert, they found that over time, their ingenious use of water carried a high environmental price.
They probably suffered very much from what some parts of Southern California suffer from, and that is salinization, where too much salts enter the soil. The basic story is that if you bring too much water to the land, a lot of it evaporates, leaving the minerals in the ground. Eventually, you can't grow crops on it.
Ironically, the Mesopotamian skill at creating and utilizing desert technology proved their undoing. They pushed the environment beyond what it could sustain.
This is the kind of decision that I think the past illuminates for us. The greatest, most gifted people also fell prey to short-term maximization without respect to the consequences for the long term.
Thousands of years after the Babylonians' efforts to beat back the desert, modern developers would create desert cities like Phoenix, Arizona, that would also push the arid environments to the limits of sustainability. For every 100 gallons of seawater that enter a desalination plant, 15 to 50 gallons of fresh water are recovered. Desert Tech will return on Modern Marvels. last 50 years or so, Americans have found ways not to just survive in the desert, but thrive. And yet, there is a double-edged sword. The story of Phoenix, Arizona is a cautionary tale of how people can create and implement technology to conquer the desert, but in the process, threaten the environment that sustains them.
We use hundreds of gallons a day per person in Phoenix, and that kind of irresponsibility is something we really need to think seriously about.
From 1980 to 2000, the Phoenix metro area doubled in size. It now bursts with economic opportunity, sprawling with homes, hotels, and highways. With a population of over 3 million, it's one of the fastest growing regions in America, with no sign of slowing down. Phoenix, like ancient Mesopotamia, has scant rainfall, averaging less than 8 inches a year. But like the ancient desert civilization which flourished in proximity to the Tigris and the Euphrates, Phoenix gets water from a river. In this case, the Salt River. It's so named because of its alkaline content, which nonetheless doesn't prohibit human consumption. 1,000 years before the first white settlers ever stepped foot onto the hot, sandy soil, Native Americans thrived here. Tens of thousands strong, they found a way to reclaim the desert and prosper in the process.
The Hohokam Indians had over 1,000 linear miles of irrigation canals.
Archaeologists today are still amazed at the sophisticated nature of their engineering that went into their canal systems. The Hohokam were able to take water away from the several perennial rivers that existed in the desert and transport it dozens of miles to large villages that were tending to thousands of acres of farmland.
However, like the Mesopotamians, the Hohokam culture eventually died out. Did the desert defeat them? With scant evidence, historians can only speculate.
They face the same challenges that we face today. How do you get along in a marginal desert environment? How do you use the most precious resource of that environment? It's water. These issues that are important today were important to them, and the better we understand on how they tackled those challenges, I think the better prepared we'll be for our future.
The first white settlers who tried to tame Arizona's desert in the mid-19th century picked up.
That was excavated in 1878, and this canal was one of the very first ones that delivered water to thousands of acres of farmland to the early Euro-American settlers, and is still in use today, well over 100 years later.
When it came time to name their town, the settlers reasoned they were creating something new from the ashes of the past. Inspired by the mythological bird which did exactly that, they deemed Phoenix an appropriate choice. For the next century and a half, the city would live up to its name.
It was a boomtown, but a boomtown based on land and farming and irrigation water. They organized themselves, they lobbied in Washington.
The settlers needed the government's help, and the government wanted to settle the West. As a result, the U.S. Bureau of Reclamation was established, with the specific goal of providing water to southwestern farmers.
The first major U.S. reclamation project was the construction of Roosevelt Dam to impound the waters of the Salt River, to make it available for irrigation in a more orderly fashion, and just multiplying the potential.
A dam of this size had never been constructed. It was 280 feet high and 723 feet long. Furthermore, the project marked the beginning of hydroelectric energy production. Now with water and power and lots of inexpensive land, Phoenix had nearly all the basic building blocks for a modern community. Except that it was a desert with unbearably hot summers. So when air conditioning was introduced decades later, after World War II, it made all the difference in the world. Gettle Air Conditioning was the first to adapt Willis Carrier's 1902 invention to the Phoenix area. Its units weren't cheap, but they did the job. An air conditioner is basically a refrigerator without the insulated box. A compressor pressurizes a refrigerant, usually Freon gas. The pressure forces it to heat up. This hot gas runs through a set of coils in order to dissipate its heat, condensing it into a liquid. The liquefied Freon then runs through an expansion valve, where it evaporates to become cold, low-pressure Freon gas. This cold gas runs through a set of coils that allows the gas to absorb heat and cool down the air inside the building. In the 1960s, air conditioning technology like this became mass-produced and affordable. That changed everything for Phoenix. People no longer perceived its desert climate as a drawback.
We have 3 months a year here where the average high temperature is well above 100 degrees. Air conditioning, today most of us wake up in an air-conditioned home, get into an air-conditioned car, go to our air-conditioned offices, and it may be 110 or even 120 degrees outside, but we live in a world that's forever 75 degrees Fahrenheit.
You could really weather this heat, and then the rest of the year it was spectacular out, and so you were happy to be here.
But was it too much of a good thing? With a population that rose from over 300,000 in 1950 to over 3 million by 2000, the climate of Phoenix actually changed.
Population growth has really created two changes in our climate. First is humidity. Because of the swimming pools and the irrigated golf courses and front lawns and things like that, we've created several points higher average humidity here in Phoenix than originally existed.
Phoenix's second climate change is a phenomenon called the heat island effect.
All the heat from the solar radiation during the day is stored in our parking lots and in our roads, and it just emanates overnight. And one of the big problems that has is that the nighttime temperature of many of our desert cities has gone up as much as 15 degrees Fahrenheit from what it used to be.
As the 21st century dawned, Phoenix had become trapped in a vicious cycle.
That 15 degrees has got to be swallowed by air conditioning. And that air conditioning, of course, lets even more heat out into that night air. So we've got a very serious problem there.
While these problems didn't develop overnight, they were anticipated as early as 1970. There was concern in some circles that if the result of all this desert tech was a generally flat urban sprawl, then perhaps some rethinking was in order. This led to the creation of an experimental alternative community called Arcosanti, located 70 miles north of Phoenix. A collection of eclectic, densely packed buildings. It was steeped in the kind of desert tech employed by the ancient Mesopotamians, low tech, but effective.
The sun is rising out here to the northeast, arcs high in the sky, and sets over here to the northwest, so the entire building shades right out to this curve, in fact. It is passive solar architecture. The building is really working with the annual regimen of the sun to create an environment that is a warm environment for the winter and then a shaded environment for the summer.
Arcosanti was the brainchild of Italian-born architect Paolo Soleri, who felt Phoenix was conquering the desert instead of adapting to it.
Phoenix is indifferent to the desert, so I had my alternative, which is, I call it the lean alternative.
Among other things, Soleri felt the need for air conditioning could be minimized by construction materials that could offset extreme desert temperatures.
In the desert, the primary surface that you want to be aware of for insulation is going to be the roof, the horizontal surface, especially in the heat of the summer. This has about 4 inches of sprayed foam insulation, which is very effective at mitigating overheating in a concrete structure.
Besides adapting to the sun, Arcosanti's oddly shaped roofs also maximize water conservation. Water captured during sudden downpours drains down to collection vessels.
What we're trying to do here is to use what water we have responsibly.
Despite its common sense approach to desert tech, Arcosanti failed to catch on, never growing beyond a community of several dozen people. Meanwhile, Phoenix continued to explode, but its very success led to serious water issues. Problems developed in Phoenix's aquifer, where underground water was trapped millions of years ago.
Phoenix obtained a considerable amount of their water resources from groundwater. Historically, over time, this has resulted in rather significant drawdowns in the aquifer, ranging anywhere between 50 and 100 feet. This has caused subsidence in some parts of the valley. For example, over at Luke Air Force Base, it's dropped nearly 18 feet.
In other words, Phoenix is sinking and has been for decades.
Arizona pretty much was persuaded or forced by the federal government to come to grips with this. And it instigated a really innovative law called the Groundwater Management Act that in fact put all sorts of constraints on new farming. It put incentives for water conservation among the cities. And it set a goal of balancing natural recharge with extraction rate.
Man should always strive to be in balance with the desert because it is a challenging environment to live in. We are increasing our population size and therefore the carrying capacity of the land. And so we need to be smart about it.
Phoenix's highest recorded temperature was 122 degrees on June 26, 1990. Desert Tech will return on Modern Marvels. In the 21st century, surviving a journey or camping in the harsh environment of the desert isn't just possible, it's the norm. A variety of survival gear is readily available at one's local outdoor outfitters. These modern methods have their roots in the time-tested ways of the Middle East's nomadic Bedouin tribes.
The traditional Bedouins were the ultimate in desert dwellers. They were able to adapt by being mobile, by practicing seasonal movements of their flocks, with a relatively low technology.
Bedouins could travel on their camels hundreds of miles across the desert. Part of their secret was knowing that the seemingly barren landscape wasn't quite as barren as it appeared. Knowledge of the locations of water sources across the desert were passed down from father to son.
Even today, you ask some Bedouin people living in southern Jordan, for example, they know where to find water. They can dig holes in the bottom of wadis or streams and usually find some amount of water to subsist on.
Depending on the area, water could be found by digging relatively shallow holes. And because water found in the desert sand is typically too hot for bacteria to live in, it usually doesn't require purification, only straining through cloth to remove sediment. With life-giving water, the Bedouins could survive. But what about exposure to the sun? The Bedouins' clothing, consisting of a headcloth called a keffiyeh and a dark tunic, covers them from head to toe. This protects them from the sun. The loose-fitting tunic also keeps them cool by allowing air to circulate. But because the air is trapped within the material, it also prevents their sweat from evaporating too quickly, thus slowing down dehydration in the hot, dry air. The Bedouins' simple tents, like their clothing, belied an ingenious low-tech design tailored for desert survival.
They are made out of camel hair. And those tents are fairly loosely woven so that there's plenty of air that gets through the tent. It isn't an impervious layer. It is actually allowing the air to flow through it in a very free way.
At the heart of every Bedouin's desert survival strategy is the camel.
The camel is this extraordinary animal. Not only is it able to survive without regular water, but it carries very considerable loads.
Camels can carry their Bedouin riders across the Middle Eastern desert without water for 25 days in the winter, 5 in the summer heat. In America, most people travel across the desert in air-conditioned comfort on superhighways. But the desert has also become a popular place to hike, camp, or ride in off-road vehicles. How does one survive a day or two in the desert? Proper preparation is vital. The most basic supply is water, carried either in a canteen or the more recent hydration pack. But what if you run out? You can find water by looking to nature. Flies and mosquitoes are a sure sign water is in the vicinity. And bees will fly to and from water in a straight line up to 1,000 yards away.
And what you're going to need to do is actually capture that water, but also you're going to need to clean that water through a water purifier. And the way that it's used is you actually just unscrew the bottom and it screws onto the top of the bottle. And then once that's in the water, you just begin to pump. At this point, the water's going to come up through the tube and down into the bottle. And you can drink it after it comes out through the filter.
Besides water, another key to desert survival is protecting your skin. The desert has an abundance of sunlight that carries harmful ultraviolet radiation.
The ultraviolet light that reaches the Earth's surface is really three types. There's UVA, there's UVB, and there's UVC. The majority of what reaches the Earth's surface is the long wavelength UVA radiation, and that does have damaging effects on the skin for aging the skin and causing skin cancers. The UVB is the middle range of wavelengths, which tends to cause sunburns and skin cancers. UVC really doesn't play a significant role in your day-to-day exposure.
The first line of defense is protective clothing.
The big myth is that regular clothing will protect you from sun exposure. In fact, a regular men's white cotton shirt or cotton t-shirt only has an SPF rating of around 6. More darkly colored clothing or more tightly woven clothing will protect you, to a stronger degree. But just your regular, daily street clothing, you're still getting UV exposure through that.
When you're out in the desert, you're going to be exposed to the sun in very high heat. And one of the best ways of protecting yourself and keeping yourself safe is by the clothing that you actually wear. This hat right here is actually referred to as the Sahara hat. And what makes this hat special is that it does block the sun, but it does have an ultraviolet protection of 50 on it. It has a very wide brim, a 4-inch on the front, and it has a veil in the back to protect my neck.
In addition to hats, outdoor outfitters sell shirts and pants that have been chemically treated and have an SPF factor of 50. Sunglasses that block out UV rays will save your eyes, and a good sunscreen will literally save your skin. 2 varieties of sunscreens help protect skin in 2 different ways. Chemical sunscreen acts by converting the ultraviolet rays into heat, which simply dissipates into the air.
The physical blocking agents just sit on the skin. They don't interact with the light for the most part. They just reflect it back off the skin surface. The better sunscreens on the market have a combination of both the physical blocking agents and the chemical sunscreens. That way you can get the broadest spectrum of coverage for both UVA and UVB exposure.
Ultimately, the best way to survive in the desert is to prepare for extreme sun, extreme heat, and extreme dehydration. But if your vehicle breaks down or you get lost, your only hope may be if someone alerts the search and rescue team. To help maintain body temperature, the average human is equipped with 2 to 4 million sweat glands. Desert Tech will return on Modern Marvels. Outside the town of Barstow, California, deep in the Mojave Desert, weekend warriors like to immerse themselves in Desert Tech. They get out on their ATVs or dune buggies for some excitement and fun. But sometimes a miscalculation can put lives in jeopardy. The desert is a harsh environment, which outdoor enthusiasts sometimes fail to respect.
Unfortunately, a lot of times these individuals become overcome by the elements and it results in death. A lot of times our missions are recovery missions more than a rescue mission.
Barstow's Sheriff's Department, the Reserve Off-Highway Vehicle Enforcement Unit, and the Search and Rescue Team stand ready to launch any necessary life-saving operation.
We have a report of a lost or missing dune buggy rider.
They stay sharp by staging mock rescue missions.
A typical scenario would be a group of campers possibly out for a weekend event. One of the campers may go for a ride on an ATV or possibly even a hike, and they quite simply can't find their way back to their camp, and they continue to travel many times in the wrong direction, which just takes them farther away from any help.
This mock rescue operation, like most real emergency situations, starts with a missing person call to the sheriff's station.
They just underestimate the environment. They come from more populated areas where one block to the next is easy to locate. They get in this environment of thousands and thousands of square miles of very rural land, and they just underestimate the capabilities of Mother Nature. We got guys, a white male, about 30, took off from camp in a little white.
Out in the desert, the off-highway vehicle unit is already in place with a remote command post. They'll coordinate the training mission with the search and rescue team.
They have workstations constructed in them.
8 Rescue 48.
Radio equipment is installed, and a lot of electronic devices. It's shelter for our people conducting the search who may be there for days.
The centerpiece of the off-highway vehicle unit is its dune buggy, the ideal technology for traveling on the desert's rugged terrain.
It's based on the old Volkswagen Beetle, and it's been modified from that point to handle the extreme environment it operates in. And we've had a few things added for police work and search and rescue. Some of the first things we've added are the sheriff's radio. We have a GPS unit. The suspension is coil-over. You can move the adjusting nuts up and down, and you can change the weight of the springs depending on the circumstances you're going to be using the car in. On the rear, we've got a large lug-style desert tire. It affords good traction in the desert-type environment. The engine is basically a Volkswagen-style engine. It's been bored and stroked out to 2,275 cc's. We're running a single Weber carburetor, a special extractor-type exhaust system, all of which is designed just to add more power to the car. It's got a special air cleaner on it that will handle the dust. We clean those quite often just to keep that out of the engine.
Dune buggies first emerged in the 1950s, when California's beach and car cultures merged. Old Volkswagens were cheap and plentiful, and were easily modified by removing most of the body. Lightweight and great on the sand, they were popular with off-road enthusiasts who took them out to explore the Mojave Desert. The search and rescue team also has all-terrain vehicles. So does the off-highway vehicle unit. Though they're typically standard production models, they're particularly well suited for desert travel. These types of ATVs were first developed in Japan. They were originally used as farm-to-town vehicles in isolated mountainous areas. Then they caught on as off-road recreation vehicles. Eventually, law enforcement saw the ATV as a valuable technology in its desert rescue arsenal.
This is a 2001 Honda Rancher 4x4. It has the capability of going just about anywhere I need to be able to go. We work in a severe environment, dealing with extreme heats on one end and then extreme colds on the other. The Honda offers good stability with the suspension system. I'm allowed to be able to climb about a 30% grade under severe heat and rocky conditions.
The advantage of the ATVs, they're very versatile. The technology in the ATV industry is very advanced. The equipment is four-wheel drive equipped now. We can pack a lot of equipment with us on those types of vehicles because they are versatile and large. And you can just quite simply cover a lot of ground with the use of the ATV.
4.6.
What?
Okay, 4.6. No.
The light set.
So you come over here.
GPS technology and three-dimensional mapping, programmed with information provided by the missing person's friends, are critical to the rescue efforts. At this point in the training scenario, the team has located the missing man's vehicle. The tracks of the missing man in the training scenario are located a short distance from where his vehicle was found. Members of the search and rescue team set up a tracking stick and mark the tracks as the next step to locating and rescuing the victim.
Track here.
The team will measure the footprint and the stride. Now they have an indication of his direction. The search continues.
Man down by a bush.
In the final stage of the training mission, the missing man is located, and not a moment too soon.
As you can see, we're just going into nightfall. It would have been a very dark night out here in the desert, and most certainly down into the 30-degree range or maybe lower.
1, 2, and 3.
And the clothing that this particular victim in this scenario was wearing, it's very likely that his fate would have been terrible. He probably would have died from the elements that he was exposed to had he been faced with spending the night out here. It's very likely, or it's very probable, that all of the technology aspects that we used today played a very large part in saving this man's life today.
Desert technology not only saves lives, but also offers the possibility of saving the environment. Solar tech may someday mitigate our reliance on fossil fuels for our energy needs. According to a recent study by the U.S. Consumer Product Safety Commission, ATVs annually cause over 600 deaths and 125,000 injuries requiring trips to the ER. Desert Tech will return on Modern Marvels. While a variety of technologies has been brought to bear to make the desert bloom, alternative energy technology is seen as a way to turn the desert into a source of environmentally clean, renewable power. We're all too aware of the rising prices of fossil fuels and the possibility they'll run out in the next 50 years. So in the deserts of America, with over 300 sunny days a year, the possibilities of solar power are certainly enticing.
As technologies for solar conversion to electricity will become more reasonable, I think we're going to see a solar generation here. We're going to reach a tipping point where this is going to become the way to do it, and in the future will give a whole new generation of excitement to cities like Phoenix.
Arizona Public Service, otherwise known as APS, is one of the desert's leading solar energy utility providers and research centers in Arizona. Their program has a residential and commercial component, with about 1 million customers throughout the state.
We do live in the desert, and the sun is our most abundant resource, and it's an obvious choice to get involved in developing solar to provide our customers with the energy they need. And so it was a natural for us, and we've been doing it robustly since the late 1970s, and working on the technology to bring down the cost.
A big drawback for solar is that it stops at night and on cloudy days. It costs 15 to 30 cents per kilowatt hour, while fossil-fueled power generators can run day and night at only 4 to 11 cents per kilowatt hour. One method of converting sunlight to power is thermal, which uses the heat from the sun to generate electricity. Sun-tracking mirrors, called heliostats, focus solar energy on a receiver atop a tower. From here, the thermal energy moves on to boil water, which converts to steam and then spins a turbine generator, as in a conventional power plant. A second type of solar technology is photovoltaics.
Photovoltaics is the direct conversion of sunlight to electricity using semiconductor materials. The sort of systems you see behind me, in those, photons of light actually dislodge electrons from their orbits inside the material. Those electrons are then available to carry a current in an external circuit.
To create higher efficiency in photovoltaics, new approaches are being tested in APS's STAR facility in Phoenix, which for them is Desert Tech Central.
These high concentration arrays do have the potential to considerably cut the cost of solar energy. We're harvesting the sunlight over a large area with a relatively cheap plastic lens. The lens concentrates the sunlight 250 times onto a small, high-efficiency solar cell. It's only about 1 square centimeter in area. The size and location of the solar cells is indicated by these little squares on the back side here. So this system is usually using 1/250th of the amount of silicon that would normally be used by a more conventional photovoltaic panel, which means we're using a lot less of the more expensive material, which means, again, that this does have the potential to be one of the low-cost generators of solar electricity.
Here's the energy of the future. It might be 10 or 20 years before it really breaks into the marketplace in a cost-effective way, probably closer to 20. We recognize that as a utility. That is the future.
Why can't we as a country liberate ourselves from the dependence on fossil fuels with a technological leap that captures that energy at an economic level? We should be able to do that. And actually we're slowly encroaching on it, very slowly, but we're a long way away from it yet.
While the widespread application of solar energy is still far off, it has a potent application in NASA's exploration of outer space. The Mars rover uses solar energy to keep it powered up millions of miles from Earth.
They have solar cells on top of them, just like on the tops of homes in desert environments. They collect solar energy, and we actually store some of that energy in batteries if we don't use it during the day's operations.
Before NASA created the rover, it took its cue from a familiar aspect of desert tech, the dune buggy.
Dune buggy design, any sort of off-road vehicle design, was looked at extensively as we developed these Martian rovers. We primarily looked at the ability of these systems to go over natural terrain environments. And so we had to essentially replicate within these Martian rovers the capability for going over natural terrain.
The desert has become a frequent outdoor lab for NASA as it tests the capabilities of the Mars rover.
Our rovers are put in these environments so that we can learn how to do remote field geology, robotic field geology, through the eyes of a rover, a robotic device. Since the environments are so similar in terms of the geology of the rocks. Our principal reason for going to Mars today is to understand whether the past of Mars was a harbor for life. Could it have been a habitat for life, being a warmer and wetter planet than it is today? They may tell us clues about where the Earth is going. Does Earth have that same history ahead of it? Will it end up as a desert like Mars is?
Space exploration, solar power, new opportunities for people to have a better life. So much of what we do and learn in the desert presents exciting applications of technology. But scientists and historians caution us to remember our history lessons of desert civilizations that disappeared. We must never forget the #1 axiom of the desert. It's all about the water.
We need to maintain a balance, a good relationship with the desert, and that means conserving resources, making sure that we're smart about our use of water. And so while technology is a wonderful thing, it's not everything, and we need to be careful that we don't come to rely on that exclusively, because good decision-making is just as important as good technology.
For now, the desert communities of the world have enough water. This, among other reasons, continues to make them attractive to ever more newcomers. So the ultimate question is, how long can technology tap into the resources of the desert before the desert stops providing? Only time will tell. Increasingly relied on desalinization, also known as desalination. This is a process that removes salt from seawater. Seawater from 5 surrounding oceans and seas can be diverted toward the desert's populated areas for drinking, bathing, and irrigation.
About 90 to 95% of the water in the world is salty water, and you can't use it. Desalination has to be a part of our long-term water resource management strategy.
The salt content of seawater is approximately 33 to 34,000 parts per million. That content must be reduced to just 350 parts per million to make it drinkable. To accomplish this, desalination plants run a widely used system called reverse osmosis.
To live in what are some pretty horrendous environments by anybody's standards.
Our religions grew in desert environments. The desert is a testing environment where you find out what you're really made out of.
In order to live here, people have had to organize, invent new technologies. People have had to come to grips with living within the environment in a way that they weren't forced to in many other parts of the world.
In the Middle East, where arid desolation dominates the landscape, people are surrounded by great bodies of water. But none of it is drinkable. Still, desert technology allows millions to live along the coastlines. Since the 1970s, as its oil-rich societies have expanded, the Middle East has increased. The desert. By day, the sun beats down hellishly without mercy. On a winter night, the chill wind blows through canyons with an icy fury. But it's really all about the water. Deserts typically get less than 6 inches of annual rainfall, so finding and maintaining a water supply means everything. It's an enormous challenge. Some 40% of the Earth's land is desert. So throughout time, man has, by necessity and by choice, had to cope with it, cross it, survive it.
We started out in the desert, and we've evolved increasingly sophisticated technologies that have allowed people.
After water is pre-treated to remove common marine debris, it flows through a pressurizing unit and then travels through a filter porous enough for water to flow through, but too small for salt molecules to penetrate. Once completed, the process yields a waste byproduct of salty water that must be discarded.
So the question is, what do you do with the salty water? Living near the ocean or the sea, you can dispose of this right back into the ocean and the sea. So that's why that makes sense in the Middle East.
Desalination requires a lot of energy and is therefore extremely expensive. It costs over $650 per acre foot to desalinate seawater, as compared to about $100 per acre foot to purify water from conventional freshwater reservoirs. Sweltering heat, icy cold, and hardly a drop of water. The death trap they call the desert. Yet through man's ingenuity, he's not only survived, but thrived here. The complexity of irrigation systems, the comfort of air conditioning, the promise of solar energy. From ancient times to the present and beyond, man has transformed barren wastelands to worlds of wonder. Now, Desert Tech on Modern Marvels.